Hey, welcome back. So this is the final exam review, and I think the best way to study is just to kind of go back over your in-class tests and find similar problems in the book. So what I'm going to do in this review is um, tell you what kind of questions to kind of expect, do, probably like 4 or 5 problems from each test, and hopefully that will be good enough. So from test 1, you can expect anything like problems 1 to 24. Okay, so looking over here on the right, that's test 1. We begin with factoring. Just at first we were factoring out the GCF, so like problems like 18y squared plus 12. What's the biggest thing that divides into 18y squared and 12? Well, looks like 6, right? So you'd be left with 3y squared plus 2. And then that would be all you could do in that case. Something you might have forgotten about was that grouping stuff, like in problem 4. And the directions for this set of problems, completely factor. Okay, so completely, we're not solving or anything like that, just completely factor. Okay, so problem 4 was kind of one of these grouping things. I have 3x squared minus 6xy plus 5xy minus 10y squared. So group these first 2 guys together and the second guys together and pull out their GCFs. Okay, so in the first group, you can pull out a 3x, and you'll have x minus 2y. And then the second group, you could pull out a 5y, and you'll have, again, x minus 2y. And then from those terms, you could factor out this common binomial, right? So you could factor out an x minus 2y, and you'd be left with the 3x plus 5y. Okay. So a lot of people forget those guys are in here. The other problems are just kind of like, regular old factoring, like number 6. I have x squared minus 2x minus 8. So you set up your parentheses, you get the sign, so it has to be plus minus. It's going to be x and x. And then what times what is 4, but add what times what is 8, but add then to be negative 2. So you want 4 and 2 with the bigger number negative. And then, multiply it out in your head and make sure it works. So first, outer, inner, last, and yeah, that works. Okay, so all that factoring stuff was in there. Multiple variable factoring, so like number 7, you have x squared minus 3xy minus 18y squared. So you're setting up your parentheses just like before. The signs have to be plus minus in this case, and you'll have an x, and then something y, right? Need numbers that multiply the 18 but subtract to give me 3. So I need 6 for the negative portion, and then 3, and then that should do it. So make sure it works. X first, outer, inner, and then last. Add them together. Yeah, it works. Okay. There were special forms in here, so difference of squares, like problem 13. Problem 14. So problem 14, I guess we'll try. I have 49y to the 4th minus 16. So try to factor that. There's no common factor, so usually you want to look and see if you can factor anything out first before you start. Factor out the GCF first, right? But anyways, this will be 7y squared, 7y squared, and then plus 4 minus 4. And then there's no farther, you can't go any farther. Sometimes you can go farther, right? So like number 19, you can keep on factoring number 19. We have 7x to the 4th minus 7. So first you can factor out the GCF of 7. Then you have x to the 4th minus 1. And then you could factor x to the 4th minus 1. That's x squared minus 1 times x squared plus 1. And then you're not even done. You could still factor that. That's the difference of squares. So you got 7 times x minus 1 times x plus 1 times x squared plus 1. And then that's the final answer. Don't forget you have cubic formulas that you have to have memorized, the SOAP formulas. So like for number 17, you have y cubed minus 125. The formula was a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And the SOAP, same sign, opposite, and then always positive. Okay, so in this case, a is y, b is the cube root of 125, which is 5. That's supposed to be a cube. And then you'll have y minus 5 times y squared plus 5y plus 25. Okay. So you have to know that. Also the addition version in number 18, I see 27x cubed plus 8. So using SOAP, we just have different signs this time. So same, opposite, always positive. The a value here looks like 3x, and then the b value here looks like 2. So you get 3x plus 2, and then over here you get 9x squared minus 6x, and then plus b squared is 4. Okay, so those are your basic factoring problems. So go through those, make sure you can do it, find ones in the book that are similar. Look at my review from test 1. That's a great place to go. 21 to 24, you're actually solving now. So solve the equation. So like 22 there, let's look at that guy. I have x squared plus 2x equals 15. I'm going to move the 15 to the other side and then factor. So I have x plus 3, x, I want to go plus 5 and then minus 3. Equals 0. So factor it and then set each factor equal to 0. So you get x equals 3. And then x plus 5 is 0. So you get x equals negative 5. Those would be your two answers. 24, for some reason, a lot of people screwed that one up on the test. So let me look at that. X cubed minus 7x squared plus 10x equals 0. Factor out the x. So you get x times x squared minus 7x plus 10 equals 0. Then factor that polynomial there. So you can factor it into two binomials, x minus 5 and 2. Okay, so this is where people screwed up. One of the solutions, you have to take that factor of x and set it equal to 0. So one of the solutions is x equals 0. Okay. Then you take the x minus 5 and set it equal to 0. So you get x is 5. Then you take the x minus 2 and set it equal to 0. So x is 2. So you can have, for these kind of equations, multiple, not just two answers, but you can have 3 answers. And if they get more and more complicated, like you'll see in college algebra, you can have 4 or 5 answers. Okay. Okay. So make sure you can do that. Like I said, a lot of people screw that up on the test. Let me make sure I'm still recording. Hello, hello, hello. Okay, looks like it's okay. I won't put the story problems on the test. So if you see on test 1, I'm only going to consider problems like 1 to 24. I can't use the same problems because I've had so many people like try to cheat that way. Like they'll just put all the answers to the test somewhere and then use it, So I can't do that anymore because somebody decided to cheat. One bad apple spoils the bunch, Anyways, section 2. And I know cheating is sometimes you get desperate, like, just nothing is going your way in life and it happens, but I have to protect myself from that because kind of our accreditation as a college is dependent on making sure that people don't cheat. So anyways, test 2, we're working with rational expressions, basically like fractions, right? And we want to be able to simplify them, multiply them, divide them, add them, and subtract them. Okay. So we want to go through and take a look at some of these. We begin with simplifying. So just simplify are the directions. Let's look at number 3. So that looks annoying. X squared plus 12x plus 36 all over x squared minus 36. So the key to these is to completely factor and remove common factors from the numerator and denominator. Right, so here in the numerator I can factor this into x plus 6 times x plus 6. And the denominator I could factor it in the x plus 6 times x minus 6. And then you see the common factor of x plus 6. And then it's x plus 6 all over x minus 6. And you're done. Okay, so completely factor and remove common factors. Multiplication is kind of the same deal. Let's look at number 6. That looks intimidating. So we have y squared minus 7y minus 30 all over y squared minus 6y minus 40 times 2y squared plus 5y plus 2 all over 2y squared plus 7y plus 3. Okay. All right, so first things first, you want to completely factor as you multiply across. So that first polynomial, that first quadratic, is going to be y plus minus, it's like 10 and 7, right? So 10 and 3, 10 and 3. All right, the next term from the second factor in the numerator, we have so it has to be 2y and y. It's going to be plus and plus, and then 2 and 1. So I need the 2 over here to get that 5 in the middle. Downstairs, factoring the first trinomial, I'll have y, and then plus and minus, and then 10 and 4. Okay, so 10 on the bigger one, 4 on the smaller one. The next, we have 2y and y plus. I need the 3 over here to get that 7 in the middle, and then 1. Remove your common terms, common factors, those, and you're left with y plus 2 all over y plus 4, and that's it. Okay, so just factor, remove common factors. Let's move on to a division problem, number 8. People think that one's tricky, but it's really not. Y squared minus 16 divided by y squared plus 3y minus 4 all over y squared plus 4. So the first step for these is to take reciprocal of the second term, right? The first term you can re-envision as y squared minus 16 over 1 if you wish. But the second term, you change division in the multiply and then take the reciprocal. So you'd have y squared plus 4 all over y squared plus 3y minus 4. Okay. Now you can start factoring. So y squared minus 16 is y minus 4 times y plus 4. And then y squared plus 4, you can't factor that. That one's prime. And then all over the 1 times y squared plus 3y minus 4, factoring the y squared plus 3y minus 4, you're going to get y, let's see, we need plus 4 and then minus 1, y minus 1. Okay, the plus 4's cancel, and you're just left with y minus 4 times y squared plus 4. No need to FOIL that out, just leave it like it is, all over y minus 1. Okay, so division and subtraction. Then we need to do adding and subtracting. In particular here you see the first two, have common denominators, so there's not much to do. Don't forget to distribute the negative in the second numerator. Then unlike denominators, so let's do some, these are subtract or add depending on the circumstances. Let's try number 12. So I have 5y all over y squared minus 9 minus 4 all over y plus 3. Okay, so in that first denominator, I want to factor it, kind of look under the hood and see what I'm dealing with, right? So y squared minus 9 is y plus 3 times y minus 3. And then I have minus 4 all over y plus 3. Okay, I want both denominators to look the same. So that second denominator is clearly missing a factor of y minus 3. So I need to multiply top and bottom of it by y minus 3. Once you do that, you have a common denominator, and all you need to do is subtract the numerators over the common denominator. So you have 5y minus 4 times y minus 3. I'm going to need to distribute all over y plus 3 times y minus 3. Okay. So distributing here, you end up with 5y minus 4y plus 12 all over y plus 3, y minus 3. Okay. And then I want to combine like terms. So 5y minus 4y is y, and then plus 12 over y plus 3, y minus 3. And then hopefully you can simplify a little. No, can't. Not in this case. Sorry, Charlie. No luck. Okay. Let's look at another one of those. Try, I guess, 14 there. So I have y plus 3 all over 5y squared, and then minus y minus 5 all over 15y. Okay, so you can factor the denominators if you need to. This is 5 times y minus y minus 5 all over 15 is 3 times 5, and then there's a y. And then you're multiplying in to make the denominators look the same. So the first denominator is missing a 3, so I need to multiply top and bottom by 3. The second denominator looks like it's missing a 5, so I need to multiply top and bottom by 5. But it's also missing a y. No, it has the 5. I take that back. It's just missing a y. Right? Because you don't want to over multiply. That's bad news. That just makes things worse. Okay. So I think the denominators are the same now. It should just be 15y squared. So subtracting the numerators over the common denominator, I have 3 times y plus 3 minus y times y minus 5 all over this 15y squared. So this will be 3y plus 9 minus y squared plus 5y all over 15y squared. Then we can combine like terms. So I'm going to get 9 plus 8y minus y squared all over 15y squared. And there's nothing you could do to simplify there. Okay, you could try to factor that, but you're not going to get a cancellation. Okay. All right, the next part was on complex fractions. So like number 16, x over y plus 1 over x all over y over x plus 1 over x. What I want to do is multiply. So there were two ways you could do it. You could find a common denominator and add the numerator over the common denominator. I like to multiply to get rid of the denominators, right? So I need a factor of x to get rid of the x in the denominator, and I need a factor of y to get rid of that y in that first denominator in the numerator. Okay. If you do it to the top, you have to do the same thing to the bottom. Okay, so what you end up with is this times this, right? So you have xy times x over y, and then plus this times this, plus xy times 1 over x. And then all over this times this, so you have xy times y over x, and then this times this, plus xy times 1 over x. You do your cancellations. Some people just do them in their heads, that's fine. Y goes into y, and then you're left with x times x is x squared. And the second term, the x's cancel, and you're just left with y. Downstairs, you have a cancellation of the x's, so y times y is y squared. And then plus, the next guy, the x's cancel, and you're just left with y. Okay, and then there's nothing else you could do. It's as good as it gets. All right, some people had a lot of trouble with these 17, 18, 19, 20. What you're doing is multiplying to get rid of the denominators. Okay, you state your restrictions, and then, so if you do it your own way and you get it wrong, I am going to just give you +0. I won't even give you partial credit. Okay, if you want to do it your own way, that's fine, but you better get it right. Okay, that's kind of the way it is at any job. You're in trouble if you're going to try to do it in your own way and then you screw it up on top of that. Well, you need the restrictions. So the denominator, you can't have a denominator equaling 0. Like this guy, it cannot be 0. This guy cannot be 0, right? So you need to make sure x is not 0. You need to make sure 2x is not 0. In other words, x is not 0 again. That's your restriction. So basically, x cannot be 0. Okay. Once you've established that, then you want to get rid of those denominators. So you need to multiply both sides by an x. And then to get rid of the 2, you need a 2, but you need to get rid of a 4 overall, because there's a 4 in this other denominator. So you need to multiply by 4x. Okay. So distributing here, you'll have 4x times 2 over x plus 4x times 3. That'll equal 4x times 5 over 2x plus 4x times 13 over 4. Okay. And the first term, that x is canceled, just leaving you with 8. And then you get plus 12x. And over here, 4x over 2x is just 2. Times 5 is 10, so let's just write 10. And then plus the 4's cancel, and you get 13x. Okay. All right. Now you can move the x's to one side. You'll have 1x when you flip-flop sides. And then you'll have negative 2 on the other side. So the solution is x equals negative 2, assuming I didn't make any silly mistakes. I think I'm good. Okay. Let's look at another one, number 20. So really, I need you to multiply by something to get rid of the denominators. You need to state your restriction. None of this, let's do it my own way and hope for the best. Okay. Okay, so on here, the denominator, I can't have x being 0, that first denominator, and then I also can't have x minus 3 equaling 0. Okay, so I can't have x equaling 3. So those are our restrictions. I need to multiply by an x and an x minus 3 to get rid of the denominators. Okay, so in the first multiplication, this times this, the x's will cancel and you'll just be left with x minus 3. And the second distribution, the x minus 3's will cancel and you'll just be left with an x. On the right hand side, the x minus 3's will cancel and you'll have an x times x minus 2. Right, because this will cancel with this. All right, so I have x plus x is 2x, just simplifying here. On the right hand side, distribute, I get x squared minus 2x. Set everything equal to 0, so x squared minus 4x plus 3 is 0. I factor that, so I have x and x, I got minus 3 minus 1 is 0. So x minus 3 is 0, so x is 3, we think, or x minus 1 is 0, so x is 1, we think. You have to look at the restrictions. Look, x cannot be 3, so you have to toss this one in the trash, and the only solution is x equals 1. Okay. Okay, so that's the big and the small of test 2. Make sure you go over your tests, make corrections, and then also look at the review questions. So I'll probably take the questions from either my review or this actual test. Okay, but you know, like I said, I'll change the numbers just a little bit. You probably won't even notice. Test 3 then is on square roots and nth roots and stuff like that. So test 3, I'm thinking of questions. So this question set 1 to 21, basically. No, 1 to 25. So test 2 was questions 1 to 21. Yeah. And then test 1, questions 1 to 24. Yeah. Okay. So 1 to 25, like problem 2 there, pretty simple. Easy to mess up though, right? If you're having a bad day. The point of this is that the square root of a sum is not the sum of the square roots. You have to simplify the guts of the square root first. So this is 169. Square root of 169 is 13. Number 3, a lot of people butchered this problem. I don't know why. It seems relatively simple. You need to make sure that you're not taking the square root of a negative. So you need to make sure that 8 minus 2x is greater than or equal to 0. Right? And then you just solve that in. We're looking for the domain of this function. Find the domain. Okay. So you can't take the square root of negatives, is the point. I mean, you can later on, but here we don't want to. So anyways, you solve this for x. So you move the 2x to the other side, flip-flop side. So you have x greater than or equal to 2x. Flip-flopping side, you got 2x less than or equal to 8. Divide both sides by 2, you get x less than or equal to 4. Okay, so that on the number line, here's 4. It's everything less than or equal to 4. Okay, so you go negative infinity all the way up to 4 with a bracket, and that's your domain. Okay, yeah, I don't know. Anyways, cube root problems. The cube root of negative 64. Maybe you could even do that in your head. That's negative 4. Cube root of 1 over 125 is 1/5. These problems, everybody did pretty good on those. Make sure you show your work, like in number 7. 8 to the negative 2/3, rules of exponents, so that will be 1 over 8 to the positive 2/3. Then that's 1 all over 8 to the 1/3 squared. 8 to the 1/3, that's just the cube root of 8, that's 2. And then 2 squared, of course, is just 4, so 1/4. So you guys did a good job on those. The next set are just all kinds of rules of exponents. So you have to remember your rules, when to multiply exponents, when to add them. A lot of people like mix those, right? So number 9, you're adding exponents when you have like bases. Okay, so here you would have x to the 1/2 plus 2/3. Find a common denominator, that's 3/6 plus 4/6, which is x to the 7/6. And I was not tolerant of people making a mistake on that. So this is where you add. The one where you would multiply would be if you have like a parentheses, x to the 1/2 raised to the 2/3. Then you multiply. Okay, so that would be x to the 2/6, and then you have to reduce, that's x to the 1/3. Okay, so it seems like every class I take when I was beginning in math, I'd have to remind myself of those rules. So I totally get it. I'm just trying to get you to stop it. Stop making mistakes. All right, let's try number 12. So this is the case where you're multiplying, right? So I have x to the 1/2, y to the negative 3/5, and then raised to the 1/2. So now you multiply. So I got x to the 1/2 times 1/2 is 1/4. Y to the negative 3/10. We don't like negative exponents, so we drop that y to the negative 3/10 to the denominator. You get x to the 1/4 all over y to now the positive 3/10. It only changes the sign of the exponent when you do that. Okay, so there's that stuff. Make sure you could do those. Do the ones in the review. You guys did great on 13 to 16. I still remember. So let's look at problem number 15. And basically what you're doing is pulling out any perfect cubes and leaving everything else inside of the radical. So you want to factor in a way that you can see the perfect cubes. So 32 is the same as 8 times 4, where 8 is 2 cubed, right? So I'm going to be able to factor that out of the cube root. And then x to the 9th is a perfect cube because 9 is divisible by 3. And so is y to the 15th. That's a perfect cube as well. Okay, so this one will just turn into 2. X to the 9 divided by 3 is 3. Y to the 15 divided by 3 is 5. And then times the cube root of 4. Okay. Let's try 16. Maybe that's more interesting. I have the 5th root of 64 x to the 7th, y to the 16th. Okay, so here I go. 5th root of, I need to break 64 into a perfect fifth. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th is 32. 64 is 32 times 2, so I break it up like that. X to the 7th, I need to break that up in the x to the 5th times x squared. And then finally, y to the 16th is y to the 15th times y to the 1st. Okay. All right, so your perfect fifths right here, right here, right here. Move those out of the 5th root. So the 5th root of 32 is 2. The 5th root of x to the 5th is x to the 5 divided by 5 is x to the 1. The 5th root of y to the 15th is y to the 15th divided by 5, which is y cubed. And then you have your leftovers. Okay, don't forget that little 5. 2x squared y. Okay. Alrighty then. Subtracting, that's just more simple. Let's look at the these quotient ones. So let's look at number 20. So I have the square root of 500 x cubed all over the square root of 10 x to the negative 1. Okay, so here I'm going to rewrite it as a single square root. The quotient of square roots is the square root of the quotient. Okay, so you can write this as 500 x cubed all over 10 x to the negative 1. 500 over 10 is 50. X cubed over x to the negative 1. So in this case, you subtract exponents, right? So it would be x cubed minus negative 1. So that's x to the 3 plus 1, so it's x to the 4th. Then we need to move out the perfect squares. 50 is the same as 25 times 2. And the square root of 25 is 5. The square root of x to the 4th is x squared. And then we have the square root of 2. One thing you didn't have to worry about on my test was the absolute value issue, but if you keep taking math, that does come up. Just remember, in general, if x is any real number, the square root of x squared is not x. It's the absolute value of x. Okay, so hopefully that'll stick with you. If for some reason you have to take tons of more math, so maybe in the future aliens come to our planet and enslave humanity and make us sitting around doing math all day long. If that happens, you'll want to remember that particular identity. All right. Rationalizing denominators. Any human worth his weight in mathematics should be able to rationalize denominators. Let's look at 22. I have the square root of 5 plus square root of 3 all over square root of 5 minus square root of 3. The deal with these, you want to multiply top and bottom by what was called the conjugate, right? So if you have square root of 5 minus square root of 3, you want to multiply by square root of 5 plus square root of 3. That will get rid of the square roots. If you do it to the bottom, you have to do it to the top. Okay, so you're basically going to have to FOIL all that junk out. Okay, in the numerator, the first, root 5 times root 5 is root 25. The outer, plus root 5 times root 3 is root 15. The inner, root 3 times root 5 is root 15. And then the last, root 3 times root 3 is root 9. All over the bottom, so root 5 times root 5 is root 25. The outer, minus, looks like root 15 again. The inner, oh, whoops, the outer was plus root 15. The inner is minus root 15. And then the last, minus root 9. Okay. Simplify, root 25 is 5. There are 2 root 15s. And then root 9 is 3. On the downstairs, the root 15s cancel. Root 25 is 5. Root 9 is 3. 5 plus 3 is 8. Plus 2 root 15 all over 2. And then you can simplify that. You can butterfly it, right? Like this. And you have 8 over 2, which is 4, plus 2 root 15 over 2, which will just be root 15. The 2's will cancel. Okay, so definitely have to be able to rationalize denominators. Oh no. 23 to the 25, oh no. Right? So some people got it, and I'm happy if you got it. My gosh, give yourself a pat on the back. I'm proud of you. If you didn't get it, you got a little bit of work to do. All right, so the deal was you want to isolate the radical part and then square both sides. So here the radical part is this junk. What I'm going to do, because it has a negative there, I'm going to move it to the right side. I'm going to move the 3 to the left side. So I'll have x minus 3 equals 2 times the square root of x minus 3. Right? I just added 2 root x minus 3 to both sides. And I subtracted 3 from both sides. Okay, sorry that was in red. Now I'm going to square both sides. On the left, you got a FOIL, so that's x squared minus 6x plus 9. On the right, you have 2 square. It's basically you have to square both parts, right? So it's basically the product to a power rule. If you have a b squared, that's equal to a squared times b squared. Okay, so I'll have 2 squared is 4, and then the square root of x minus 3 squared, that will get rid of the square root and just leave you with x minus 3. Okay, then I'm going to simplify the right-hand side. So I have 4x minus 12, and then set it equal to 0, right? This is quadratic equations. So x moving the 4 minus 10x moving the 12 plus 21 is 0. I have the factor. Looks like 7 and 3. So x minus 7 is 0, or x equals 7. X minus 3 is 0, or x equals 3. All right. You have to check your solutions on these. Okay, and I can't take your word for it. You need to show it to me. It's like when you go into the pawn store, the pawn guy is not going to take your word for it that your guitar was played by Jimi Hendrix and is now worth $3 million. You know, I need some evidence, okay? So 7 minus 2 times the square root of 7 minus 3 is 4. On the right side I have 3. Keep the sides separate. So I have 7 minus 2, the square root of 4 is 2. It's 3. So I have 7 minus 4. 7 minus 4 is 3. Does 3 equal 3? Yes, that works. Try x equals 3. So I have 3 minus 2 times the square root of 3 minus 3 is just 0. So I have 3 is 3. They both work. Those are your solutions. Okay. 24 is pretty super duper simple. You just square both sides. I don't know. Some people still manage to screw this one up. Square both sides. So you get 2x minus 5 is x plus 4. Moving the x over, you get x. Moving the negative 5 over to plus 5 is 9. Check your answer. Square root of 18 minus 5 is square root of 13. Square root of 9 plus 4 is square root of 13, so it works. 25. Yeah, this one is hard. So if you didn't get this one, I was like, okay, I get it. This one's hard. I'm going to square both sides. That's where you start. So on the left, I'll just force the square root to go away. On the right, you have to FOIL. Okay, so it's really 7 minus x times 7 minus square root of x. Okay, so the first 49, the outer minus 7 square root x. The inner minus 7 square root x, the last, plus square root of x times square root of x is just x. Okay. All right. Simplify. So I get 49 minus 14 square root x plus x. If you move the x over, the x's will cancel. So you'll just have negative 7 equals 49 minus 14 square root x. I'm going to move the 14 square root x to the left. So I have 14 square root x. Move the 7 to the right. So you have 56. Then you want to isolate the square root x, this part. So divide both sides by 14. I think that's 4. And then square both sides. So you have the square both sides twice. Then you check your solution. I'm trying to get this stupid thing. There we go. Check your solution. Okay, so x is 16. You have to put it into the original equation, which I kind of lost. The square root of x minus 7 equals 7 minus square root of x. And plugging in 16, you get the square root of 16 minus 7 equals 7 minus square root of 16. 16 minus 7 is square root 9. So it'll equal 7 minus square root of 16 is 4. Square root of 9 is 3. 7 minus 4 is 3. That works. So your answer is 16. Okay, so make sure you get those ironed out. Don't do the same thing on the test that you did on the final exam. All you're doing is learning a bit. Headphones just broke. Sorry about that. Let's move on to test 4 then, which I haven't really graded yet. I'm making this video. This is a preemptive strike here on this video. So I'll just, not knowing how you guys are going to do, I hope you all do very well on test 4, but I'll be looking at questions, basically the whole set, 1 to 23, but I'll leave out the story problem at the end, so you don't have to worry about that. It's just 1 to 23. Solving quadratic by completing the square. So like problem 2, you have to remember it's b all over 2 squared that you're adding in. So here we go. 3x squared minus 6x plus 2 equals 0. You need a leading coefficient of just 1 on this thing, so you divide everything by 3. You get x squared minus 2x plus 2/3 equals 0. You can move the 2/3 over. That's probably what I should have done first, right? I'm going to leave a little space to complete the square. So to complete the square, it's b all over 2 squared. So negative 2 all over 2 squared. So that's negative 1 squared, which is 1. So if you add it to the left side, you have to add it to the right side. Adding 1 on the right side is same as adding 3 over 3, just getting the common denominator out of the way. Then factor, so you have x minus 1 times x minus 1, that's x minus 1 squared. On the right side, you have 1/3, and then take the square root property. So x minus 1 is plus or minus the square root of 1 over 3. Then you can add the 1 to the other side, so you have 1 plus or minus, rationalizing the denominator here, multiply top and bottom by root 3. You get root 3 all over 3. Okay. Assuming I didn't make any mistakes. It feels like I made a mistake, but I hope I didn't. Let me just kind of look at that for a second. I think it's right. Okay, let's move on then. You have to know the quadratic formula. Again, if in my imaginary scenario where aliens come down and enslave the population to do mathematics all day, if they find out you don't know the quadratic formula, you are going to be put into a re-education camp. Okay, they're going to put you in a gymnasium, and on the wall they're going to project math videos all day long until you figure it out. So A is 9, B is 1, C is 2. So x will equal negative b plus or minus the square root of b squared is 1 minus 4 times a times c all over 2 times a, which is 18. Okay, so negative 1 plus or minus the square root of 1 minus 36 times 2 is 72 all over 18. And then that will equal negative 1 plus or minus the square root of negative 71. So you have an imaginary part there. That will be negative 1 plus or minus square root of 71i all over 18. And we like to write that in 2 parts, so butterfly it as negative 1/18 plus or minus root 71/18 I. And again, you can put the I in front of the root 71/18 or in the back. I like to put it in the back. But if you put it in the back, make sure you use one of those little hooks on your square root. Okay, on the test, I'm more likely, if I put one of these graphing, I'm more likely to do number 6, the one where you have to have the formulas memorized for the vertex. So the vertex formula is negative b over 2a, and then f of negative b over 2a. All right, so anyways, we want to graph f of x equals 5 minus 4x minus x squared. I'm going to automatically just write it as negative x squared minus 4x plus 5. First get the a value is whatever the leading coefficient is. It's negative 1, it's less than 0. That means it's a sad face, whereas the math people say concave down. Secondly, you get the vertex. So here you need the formula, negative b all over 2a. So negative 4 is 4 all over 2 times negative 1 equals 4 over negative 2, which is negative 2. And then my k value is negative 2 squared is positive 4, so negative 4. Negative 4 times negative 2 is positive 8 and then plus 5. I just want to zoom in on that negative x squared, right? So f of negative 2, how does that work? I have negative and then parentheses negative 2 squared and then minus 4 times negative 2 plus 5. All right, so negative 2 squared, what the heck is that? That is negative 2 times negative 2. Okay, so that's equal to positive 4. So in my first step, I wrote just negative 4. The negative stays there, right? There's a negative there. And then it's times negative 2 squared, which we just found to be 4. So you have negative 4. Then negative 4 times negative 2 is plus 8, and then plus 5. Okay. All right. So when you put that negative in front, again, let me write it like when we originally substitute, we have this expression. And what I'm saying is you can kind of think of it as negative 1 times then negative 2 squared. Maybe that helps. So you have negative 1 times negative 2 squared, again, up here on the right is 4. Okay, so you're just getting negative 4, and that's how I get this first term. So a lot of people screw that up for some reason. All right, anyways, 5 minus 4 is 1. 1 plus 8 is 9. Then 3, we want the x and y intercepts. So the x-intercept let y equals 0. So I have 0 equals negative x squared minus 4x plus 5. Multiply both sides by negative 1. You get 0 equals x squared plus 4x minus 5. Factor that dude. So you get x, and then you get 5 and 1. And then you get, I need a plus here and a minus there. Then you get x plus 5 is 0. X minus 1 is 0. And so x is negative 5. And then x is 1. Okay. For the y-intercepts, you let x equal 0. And this is easy, right? It's just y equals 5. And that should be good enough to graph this guy. So let's get it going. The vertex negative 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if you want to draw the axis of symmetry, it's right there. Then our y-intercept at 5, 1, 2, 3, 4, 5. Our x-intercept at 1, so here's 1. And then negative 5 for the other intercept. Negative 1, 2, 3, 4, 5. Write that there. Connect the dots. Make your curve as smooth as possible. Concave down. All right, and then there you got it. Okay, so some of those. I'm not going to put those like number 7 or number 8 on the test. I won't do that. I'm probably not going to do any graphing of exponentials. You should know how to do 11 to 16 though. Those are fair game. So like number 13, I guess, log base 4 of 1/4. You're asking yourself 4 to what power is 1 over 4? Well, 1 over 4 is 4 to the negative 1, so it must be negative 1. 14, log base 2 of 1 over root 2. Okay, so you're asking yourself 2 to what power equals 1 all over root 2? 1 over root 2 is the same as 1 all over 2 to the 1/2. And then you could rewrite that as 2 to the negative 1/2. So it must be negative 1/2. You should also know these logs. Those are the two most important natural logs there in 15 and 16. 15, the ln of 1 is 0. And 16, the ln of e is 1. Okay? Because remember, the natural log is log base e. So log base e of 1 asks e to what power equals 1. Of course, that's 0. Log base e of e asks e to what power is equal to e. That's just 1. Okay. Then you should know how to expand and condense logarithms. 17, 18, 19, 20. Any of those are fair game. Let's try number 20. Here I'm condensing. I have 2 log x plus 4 log y minus log z. So first you get those you do power rules on these two guys. So you have log x squared plus log y to the 4th minus log z. Then use product rule on these. So you get log of x squared times y to the 4th minus log z. And then it's a quotient rule. so log of x squared y to the fourth, that whole thing, divided by z. Okay, and that would be your final answer. Okay, from there you had exponential and log equations. So let's look at 22. So 1250 e to the 0.065x equals 6250. And so divide both sides by 1250. Get e to the 0.065x equals 625 over 125. You can cancel the zeros. Take ln on both sides. Over here, the ln and the e kind of cancel each other out, and you just get 0.065. It's kind of like squaring both sides to get rid of a square root. And then you got ln of 625 over 125. Finally, divide by 0.065, and then go to your calculator for an approximation. So you get 625 over 125 divided by 0.065. And that'll be approximately, to 2 decimals, 24.76. Okay. Okay. No need to check the answer, but with logarithm equations, you have to check your answer. So let's look at something like 23. Here, I think we could use the definition of the log to find the solution. You have to check your answer again. Okay, so first use the product rule to rewrite it. Log base 2 of x minus 1 times x plus 1, and that'll equal 3. Then use the definition of the log, right? So this is the same as 2 to the 3 equals x minus 1 times x plus 1. Okay. 2 cubed is 8. FOIL, so get x squared plus x minus x is 0, and then minus 1. You can move the 1 to the other side, flip-flop sides, you get x squared is 9. Square root property, x is plus or minus 3. So check x equals 3. Plug it into the log. So log base 2 of 3 minus 1 is 2, plus log base 2 of 3 plus 1 is 4, equals 3. Keep the sides separate. Okay, so you're not even thinking about that other side right now. Log base 2 of 2 is just 1. Log base 2 of 4 is 2. And then 3, 1 plus 2 is 3. That's the same as the other side, so that works. Try negative 3. So you have log base 2 of negative 3 minus 1, and you're already done. You can't put 0 or a negative inside of a log. So as soon as you show me that, cross it out. That one's gone. The only solution is the x equals 3. Okay. Okay, so that'll do it for me. So like I said, go look at reviews, do those problems. I'll probably take the questions from the reviews or from the actual tests. Like I said, I'll probably have to change the numbers a little bit because somebody, like 2 years ago, cheated on a test where they had all the answers. I used to actually do all the answers and scan them and put them up, but then people started taking those and using them to cheat. So it's like anything I do that's, you know, when a teacher does something nice to help you out and then like the students turn around and use that to cheat, it's just, it blows my mind. As a teacher, as becoming a teacher, I never anticipated that, and it just was really disappointing. So anyways, you know, try to be a good student from here on out. But I mean, I know what it's like, and you know, I've had times in my life where just everything was going to crap. You know, my parents are getting divorced or whatever, and maybe my girlfriend broke up with me. I'm not able to study. I'm not able to concentrate. I understand things go wrong, you know, so I understand why people do what they do. So it's okay, but I don't know what I'm saying. But anyways, it's been great teaching you guys. I've enjoyed, this is one of my favorite classes. I just wanted to say that. I enjoyed working with you guys, and I hope the best in the future. I hope to see you in another class, and I'll see you next time. Okay, bye-bye.